All right, guys, so this is section 9.1. Now, chapter 9 is our trigonometry chapter. So we're going to be on this chapter for quite a few weeks. It's a longer chapter. I think there's 7 sections in it, but some of the sections we're going to take a couple days on, and we're going to have a few review days. And typically, this is one of the harder chapters we have all year, if not the hardest. So please be proactive in asking questions when you have them, or like don't let it snowball. Ask questions as soon as they arise. Don't think that it'll make more sense as we go along, because chances are they won't, because everything builds. All right, so section 1 is just the Pythagorean theorem. So hopefully section 1 at least is somewhat review for you, but we're going to go over it. So just to warm up, we're going to kind of just do some algebra. Now, 4 squared plus 3 squared equals x squared. Well, 4 squared, remember, is 4 times 4, which is 16. 3 squared is 9, equals x squared. Okay, 16 plus 9 is 25, equals x squared. Now remember, to undo a square, you square root it. Okay, if you square root one side, you have to square root the other. So what I get here is plus or minus 5, square root of 25 is plus or minus 5, equals x. Now some of you are thinking, what's up with the plus or minus 5? Okay, when we take the square root of 25, we're asking ourselves, what times itself equals 25? Okay, well 5 squared equals 25. So that's one solution. Also, negative 5 squared. Negative 5 times negative 5 is a positive 25. And therefore, this actually has 2 solutions, the positive and the negative 5. Okay, so for algebraic purposes, we're going to have plus or minus. Once we get like into geometry more, we don't really have to worry about this negative, because most of the time we're talking about side lengths, and we can't have a negative side length. But until we get to that point, we need to remember that when we square root something, we get 2 solutions, a positive and a negative. All right, now I want you to go ahead and do number 2 on your own. And then we'll go over it. All right, so as you work this out, you should have gotten 169 plus x squared equals 625. Done a little bit of math, and you should have got x squared equals 456. Okay, now to undo a square, we take the square root. Now, some of you want to put this into your calculator and just get a big long decimal. We're not going to do that anymore. We just spent a week and a half going over square roots and how to break this down. So from here on out, I'm going to expect you to be able to simplify square roots. Okay, so I broke it down over here, and I got 2 square root of 114, and remember, x is plus or minus 2 square root of 114. All right, so before we get too deep, we're going to go through and do some vocab here, and some of these will be review, some of them won't be. But a right triangle, as you remember, is a triangle in which one of the angles is a right angle. Okay, it's not acute, or it's not obtuse, and it's not acute. It's a right triangle. All right, the hypotenuse. It's the side opposite of the right angle in a right triangle. And we know that the hypotenuse is always the longest of the 3 sides. So, if I have a right triangle over here, here's my right angle. Okay, my hypotenuse is going to be opposite of my right angle. So if my right angle is here, it's going to be opposite of my right angle. So this would be my hypotenuse. Okay, the legs of a triangle, guys, are the 2 sides of a triangle that are not the hypotenuse. Okay, so if this is my hypotenuse, this would be one of my 2 legs, this would be my other leg. Okay, the Pythagorean theorem tells us that the sum of the square of the 2 legs of a right triangle is equal to the square of the hypotenuse. Okay, that's a lot of words, so we're going to break that down. Okay, the sum of the squares. So sum means we're adding 2 things. Okay, it's going to be the sum of the square of the two legs. So if I say legs squared plus legs squared is equal to the square of the hypotenuse. So hypotenuse squared. So leg squared plus leg squared equals hypotenuse squared. And most people know this as a squared plus b squared equals c squared, where a and b are the legs of the hypotenuse, and c is the hypotenuse of the triangle. All right, a Pythagorean triple, guys, it's a set of three positive integers. And when I say integers, I mean whole numbers. A, B, and C satisfy the Pythagorean theorem, okay? All right, Pythagorean theorem, here's just kind of a visual. Remember, the C is the hypotenuse, and the A and B are the two legs. Leg squared plus leg squared equals hypotenuse squared. And these only works, and I want you to write this down in the biggest, boldest letters you've ever seen in your life. Pythagorean theorem can only be used on right triangles, okay? Think about it. If the C squared is the hypotenuse squared, you don't have a hypotenuse without a right angle, okay? Therefore, you can't use the Pythagorean theorem without a right triangle, okay? It cannot be used on every triangle. In fact, it can only be used on right triangles. All right, so some Pythagorean triples, the 3, 4, 5 triangle, 5, 12, 13, 8, 15, 17, 7, 24, and 25. These are just quick. When you see these, you know it's a right triangle. I know carpenters use this a lot. And notice that everything here is just increased by a certain scale factor. So these four, and then any scale factor you could use. There are more Pythagorean triples, but these four are by far the most common. And like I said, this first one here is the single most common and is very, very, very popular among carpenters. All right, so let's look at example 1 now. It says, find the value of x, then tell whether the side lengths form a Pythagorean triple. Okay, well, here's our right angle right here. So we know that the leg squared plus the other leg squared can equal our hypotenuse squared. Okay, so I can say 5 squared plus 12 squared equals x squared. Well, 5 squared is 25. 12 squared is 144. 25 plus 144 is 169 equals x squared. Now, in order to undo a square, you take the square root. So this normally would be plus or minus 13 equals x. But guys, this 13 is now representing a side length, okay? So we don't need the minus when we're talking about side lengths. So 13 is equal to x. So this side is 13, okay? Now, it says tell whether the sides form a Pythagorean triple. So this is all about, do you know what a Pythagorean triple? Okay, well, is this number, and this number all three whole numbers? Because if so, this is a Pythagorean triple. And yes, these are all whole numbers, so yes, it's a Pythagorean triple. In fact, it's one of these over here, 5, 12, 13, 5, 12, 13. All right, let's go ahead and I want you to try to do number 2 on your own, but I want you to pay attention because you set it up very similar to example 1, but there's also some differences. Remember, we're going to use Pythagorean theorem, which tells us the leg squared plus the leg squared equals the hypotenuse squared. All right, so 7 squared is one leg. The other leg is x squared. The hypotenuse squared is 14. 7 squared is 49 plus x squared, and then 14 squared is 196. Okay, minus 49. I get x squared equals 147. Okay, now this is when I said don't just throw this into your calculator. We've spent a week and a half on breaking this down. That's what we're going to do. So 3 49 times, 7 7 times, 7 1 when we're done. So 7 square root of 3. Okay, so this leg here is 7 square root of 3. And it says, do they form a Pythagorean triple? The answer to this question is no. And the reason not is because this is not a whole number. All right, let's look at example 3 now. It says the skyscrapers shown are connected by a skywalk with support beams. So here's the skywalk. Use the Pythagorean theorem to approximate. Now approximate means we can round, and the reason we can round is because notice these numbers are decimals. We don't have the availability to, or we don't have the capability of simplifying radicals with decimals in them as we are right now. Okay, so we're not even going to learn that. So anytime it has decimals in it, just know that you're going to round that. All right, so if I look, and I can look at either one of these because they're congruent triangles. I'm going to look at this one here. Okay, so I'm going to use the Pythagorean theorem, which says leg squared plus the other leg squared equals the hypotenuse squared. Okay, if my right angle's here, the side across from it, this is my hypotenuse. Okay, so I could say 47.57 squared plus 23.26 squared is going to equal x squared. Okay, and if I just plug this into my calculator, I get 2803.9325 equals x squared. And then to undo a square, we square root it, and I get x is about 52.95. And then our units of measure is meters. Now, big ideas will tell you how far to round it out, so 10th, 100th, 1000th, whatever. Just make sure you pay attention to that when you have problems like this on your homework. All right, example 4 is another word problem, so I want you to go ahead and do example 4 on your own, and then we'll go over it. All right, so when you set this up, your two legs are the d and the 5, so d squared plus 5 squared equals the hypotenuse squared, which is 6. Okay, so d squared plus 25 is 36. Subtract 25 from both sides, you get d squared equals 11. And to undo a square, you square root it, so we just get d as the square root of 11. And don't forget your units of measure, which is feet.